Bismillahirrahmanirrahim. Assalamu alaikum, students. Please subscribe my channel, and if you have issues in your data analysis, you may contact me on my given email address and on my WhatsApp number for your data analysis services. In this video, I am going to explain that how we can perform simple and multiple regression analysis in SmartPLS 4 version. And here I have my base model that I have discussed with you in detail in my last videos, in which we have performed confirmatory factor analysis. I am going to simply run a simple to test the hypothesis that IV has a negative relationship with DVA and IV has a negative relationship with DVB. So simply I am going to elaborate you that how we will perform the uh, regression analysis. So this was my model. I go back to the main screen and select on the base model. First I will show that what we have done in the previous video, simply that we have developed this confirmatory factor. For confirmatory factor analysis, we have uh, draw this full model, and now we are going to perform all the analysis uh, for further analysis for mediation, moderation, or for regression. We will use this model as our base model, and we will perform all these relationship in next videos. So I am going to save this one and move back to my main screen. Just click on the base model, and here you can just create its copy, or like you can create its duplicate copy. So just I will click on its duplicate. It will me ask that what the name we will give here. Basically you can specify the copy of base model, but I am giving its name as a simple and multiple regression. Multiple regression, you, as I have told you earlier, that first you have to set your whole model, for which you have to perform the confirmatory factor analysis prior to running any or testing your hypothesis. Once you have perform your confirmatory factor analysis, take that base model, and then step by step you can perform your hypothesis testing. First, in this model I am going to just run a simple regression model with seeing the effect of independent variable on dependent variable. So I am removing all the variables here, except the dependent variable and the independent variable. So now I have just three variables here. This will show us that how we can simply run a simple model to find out the simple regression. I have in this study a single independent variable, while other two dependent variable, but you may have a in your study you may have more than one independent variable, or single dependent variable, or more than two variable. So simply you can go with that by in the same way that I have showed you in the previous videos. Just let me zoom in it. Here is base model we are going to test. I am not going to detail discuss about the its confirmatory factor analysis or other that quality criteria will be discussed with it. And I want to make this video in short, because my previous videos were in my details that are so lengthy, but these video, the next coming videos, will not be so much lengthy, except that I have to explain the things. Here's the independent variable. Dependent variable, we straight away go to the our calculate option. Again I have told you that we have all our reflective scales So in reflective scale we preferably use consistent PLS SEM algorithm. If we have a formative scale, then we will use the PLS SEM algorithm. First we run as the consistent PLS algorithm to check out the quality criteria, to check out the model fit. Then we will go with the bootstrapping option and see either are coefficient or significant or not. So here in the consistent PLS algorithm, if I click on the PLS consistent PLS algorithm, the menu will open and you have just two options: PLS setup, that now we are testing our hypothesis, or we are concerned about the path coefficients. We will select on the path. If we have to test on the confirmatory factor analysis, then we should select the factors. Here we will select the path analysis, and the result should be in a standardized form. You can choose either Einstein or mean center, but preferably it is recommended that use standardized form. Initial weight is default set, must be set at the data. There is option that you can use a different data option, or used as a weighing vector, but there is no need to set here until unless you have a specific requirement of the analysis. So we will just select here the open report option and click on the start calculations. Now simply it will take very less time for a simple model, and for long complex model it will just take time in initially bootstrapping. You can see here that in direct effect, basically the in the direct effect IV, let me zoom in. You can see here that the IV has on DVA has a positive effect, and IV on DVB has a negative effect. It has because you can see here the above the diagram, there are different options you can view in your model. The first thing is here shown here is the in the outer inner model you have the path coefficients. You can also give different select different option. It might be a blank option, it might be a indirect effects. Because we are not measuring here mediation or moderation, there will be no indirect effects. You can simply specify a path coefficient or total effects and f square values. Here we will select the path coefficients. Next, in the R square option is given in the in circle of the dependent variable. Basically that is show the within the construct what you want to show. In regression analysis we preferably choose R square or R square adjusted values, but preferably it is much better than we will choose as a R square. And when you have to testing your overall confirmatory and factor analysis, then you have different option, like to choose average variance extracted or composite reliability or Cronbach alpha. You can specify one of these options, but for regression analysis or path coefficient testing, you have to select in the R square. This will show that the overall IV's impact on DV is 0.517, and its R square is 0.267, and IV's impact on DVB is negative 0.461, and its R square value is 213. In the outer model is considered as the model that is shown in the for the factors. So this is called your outer model. In outer model, these are the outer weights are loadings of the items for this constructor, like DVA first dependent variable, and it is for the second dependent variable. You can also change here just for go with the outer loadings or with the outer weights. Definitely they have different values. Outer loadings must be higher than 0.70, and outer weights are calculated on the basis of these items values. And for both, when you select for outer weights or loading, preferably it shows outer loadings, and highlight path. If you use select it as use relative values, it will highlight the path which have the more values or more coefficients or more weights that path will be highlighted with a bold arrow. And you can also use absolute values for highlighting the path, but again here is recommended that you must off this option. It looks good for this view. Comes to the final results here, but I have just you can go through simple in a simple way to check out the construct reliability and validity of these constructs. Simple for regression correlation, some you notice that there is no issue for your cron bell f alpha composite reliability and average variance extracted. Similarly, you can check here the discriminant validity. This is a heterotrait monotrait ratios. It is also less than 0.80. There is no issue of discriminant validity. And for null Larker criteria, the all correlation values are less than the square root of your AVA, average variance extracted. So you can also check out the model fitness. It is a good model fit here, looks good, and other things are the similar. But in this all the values for the confirmatory factor analysis, we have performed the full model analysis in our previous version and calculated or validated our model. So we are not concerned about these model fitness criteria here again. We are concerned with our path coefficients. When we simply run the consistent PLS algorithm, then you have just shown here the path coefficient or beta weights or regression weights of each variable. But we are interested to get its p-value, probability value, that to check either we have a significant result or not. We will go back to our main window again here, and I will again go to the calculate option, and now we will run bootstrapping, consistent PLS SEM bootstrapping. And by bootstrapping, it will provide us the probability values of the result. Now you can see here the three options come out when we select the consistent PLS SEM bootstrapping. The first option is bootstrapping setup. You can change the number of bootstrap or sub samples here. It is recommended that it should be minimum 5,000, so we are not going to change. When you increase the sub samples here more than 5,000 or increase above number, it will take a little bit more time, and especially for complex numbers, to executing the bootstrap. So minimum 5,000 is a good one, recommended by the many authors and researchers. Amount of result, definitely it is the most important. Faster, it should be in a faster way, not in slower way. It will take more time. Percentile bootstrap is good. It will be give results in the percentile probability value. Two-tailed is preferable. You can select one tail, and I recommend you that you should use the two-tailed option. Definitely our significance level can be changed, but in most of the studies in social sciences, we select 95% confidence interval. Here 0.05 is therefore selected, and random number generated, it should be remain as the default setting, fixed. Again here we selected open report. PLS setup allow us to select either factor or path, and we are concerned here about the paths, and there is no change in data option. Just we will click on the start calculation option, and it will take, like you can see here, it is showing that it will take 23 seconds, and it's running bootstrap, and so far its value is 5%. It will just take a little bit time to execute the analysis. Just it have, I think, issue. I will pause here the video for a moment, and okay, it's executed, just writing the report, and we have the results here. Now the simplest way to analyze before going to see out the each and every option available in your left side for full report, you can easily see here, select here the for inner model analysis. You have option, either you have simple p-values, you can choose the simple p-values for the path coefficient, if the p-value is less than 0.000, it shows that your this path is significant, mean IVs has significant impact on dv and on dvb. You can also link with the path coefficient p-value, and p-value again with your, no, it's 0.517 is the path coefficient regression weight on iv on the impact on dv, and it is p-value is less than 0.0. You can also see that the all factor loadings are now values, probability values are shown here, or you can change here for outer construct model. Here the outer weights with loading p-values are simply you can choose blank, or weights loadings, outer weights loading with their t values, also p are simply p values are simply t values. Most of the other depend either you can choose you p values or t value. T for t values, its value should be greater than 2, basically for 95% confidence interval. T value is minimum criteria is 1.96. So if it is its value is greater than 1.96, it mean the result is significant, either but if you round this value, it becomes 2. So if the t value is greater than 2, it's mean this relationship is a significant. So you can also specify t values or either p values which is which is suitable for you. Now comes to the tables. This was the overview of the diagram. Definitely you can copy this diagram and show in your manuscript or thesis. So you have to select either these different options to which you want to show on your path directions on arrows. But here you notice that when we run the bootstrapping, you will not see here the r square values. When we run the bootstrap, there will be no values shown in the construct. But if you run a simple consistent algorithm, then you can have the values of r square or av or composite reliability and so on. So whenever you produce your want to copy your image and paste in your research paper or thesis, use the diagram that is generated in your PLS, simple consistent PLS algorithm, not with the bootstrapping, because that will show here the r square values and factor loadings and the path coefficient, and for their significance you can follow the definitely you have to report the table. So you just copy this table and paste there and show that either your results are significant or not. So it is recommended that you must choose the diagram from there, diagram of consistent PLS, simple consist PLS algorithm, and table from the consistent PLS bootstrapping results. This is a simple your model that we have run and got the results. It is our original sample. Basically these are the path coefficients or the beta weights, and this is the average, or you can say sample means, because in the background the software takes different sample means of the beta weights and calculate their average, and we are concerned with the original sample, not with the sample means. Either you can report both of them, but preferably it is much better that use the original sample value. It is a standard deviation, or we can say standard errors. When we divide original sample on a standard deviation, we get the t values, and if the t values are greater than 2, I have told you about the criteria, so it is significant. That is confirmed with also from the p values. Probability values are marked as green. Basically these green values show that your uh, it is the values less than 0.05, and t values are greater than 2 criteria. So these are the significant. If the values are significant, then you can your accept your hypothesis you have formulated, like my hypothesis 1a, that IV has DVA, for example, that in case it was positive effect, but I have made that the IV has a negative impact on that in this case it will be rejected. In this sense, I have made this sign negative, but actually it is a positive, then we can choose the alternative one. So on the basis of probability value, you have to select either your hypotheses are accepted or rejected. In this, as we have run here as a simple regression analysis, so we are not, we have no indirect effects, just we have the total effects that are the path coefficient we have shown there. You can also check here the further things like auto loadings, the auto loadings of each construct, but you need not to report it again and again, that have already discussed in your confirmatory factor analysis. So in this simple regression, you have no issue, and you have calculated the bootstrap and the your path analysis simply. For multiple regression analysis, simply I just change this measurement model. I have in videos I've in here see that the IV's effect on DV, but if I select the whole model and click on it, there is an option that the invert measurement model. I will click on this. Now you will see this basically makes the measurement model change for reflective to formative. Here just I go through manually, I delete it, select the delete option and click on the arrow. Now the arrow is deleted, again go to the connect, and now show the relationship of dv on iv and dvb on iv. Now you consider that these are two independent variable and one dependent variable, and simply I am performing simply bootstrapping option to show the effect of both on the this variable, and just all other things remain same. I select on the start calculation option, and it will just take us little bit time to execute the bootstrapping and give us the results. The results are I discussed for a simple regression. The multiple regression results are discussed in the same way. Just it is writing up the information, and here you have the result. In reverse direction, if I see that these two variables have impact on this variable, you can see here if I zoom in, that this A has impact on IV as a positive and significant, and DVB has a positive and negative and significant on this. Simple in the simple way, as I explained you in the first model. Change the value, you can change the values for inner model, for outer model, and so on. And for table, you can click on the final result and path coefficient. Here you will get the table results with their p values and significance. So this was all about this simple or multiple regression analysis. In next video I will show how we can perform a simple mediation analysis, then I will move to the complex mediation analysis. So for thank you very much for bearing with me.